shocking new discovery reveals a strange flash of light that turns out to be a black hole in the sky. The Zwicky Transient Facility at Palomar Observatory in California spotted an unexplainable flash of light in the sky on the evening of February 11, 2022. It issued a warning about this peculiar source of visible light and sent it out to everyone. This peculiar flare was seen in different wavelengths by as many as 21 telescopes, including the Hubble Space Telescope and the NICER X-ray sensor aboard the International Space Station. Following more observation over the course of 2 nights, it was determined that the occurrence was out of the ordinary due to the quick rise and fall in luminosity that it exhibited. A formal name was given to the source by the Transient Name Server after it was reported by the astronomers. This name is AT2022 CMC. After seeing this source across the whole electromagnetic spectrum and analyzing the data, they came to the conclusion that they had been witnesses to a cosmic event that is highly uncommon, with this discovery of this strange flash of light that turns out to be a black hole in the sky. A black hole that was in the process of devouring a star approximately halfway across the cosmos was the source of the brilliant burst of light. The remnants of the star were sent into space in the form of a jet, which was then directed directly towards Earth, where it appeared in the sky as a brilliant flash of light. But how were scientists able to determine that a black hole was responsible for the star's devouring? What occurred in the immediate aftermath of the star being ripped apart by the black hole? Finally, and most significantly, why was it so significant in the field of astronomy to make this discovery? When we stare up at the night sky, it may seem that the cosmos is at peace, but this is not the case. It's not always safe to go there. Stars eventually expire or come into violent contact with one another, and black holes consume anything that wanders too close to them. Flashes of light like these and others like them can be seen in the night sky and are referred to as transients by astronomers. In one type of event known as a tidal disruption event, or TDE for short, bursts of electromagnetic energy are emitted when a star is disrupted by a supermassive black hole at the center of a galaxy. When the star passes too close to the hole, the gravitational tidal force of the black hole violently rips the star apart into its component parts. This is analogous to the way in which the moon pushes on Earth's tides, but the effect is much more powerful. After that, fragments of the star are sucked into a disk that orbits the black hole at a high rate of speed. In the end, the black hole devours what is left of the star that was destined to die in the disk. These kinds of dynamic events provide a fresh window for researchers to investigate how supermassive black holes alter the behavior of any item that gets too close to them. Therefore, astronomers constantly search for events of this nature in the sky surveys, and the Zwicky Transient Facility is currently one of the most extensive transient surveys that is available. Immediately after its discovery, AT2022 CMC was subjected to a thorough investigation by astronomers over the entire electromagnetic spectrum. This source was found to be one of the most luminous ones ever identified in the X-ray, radio, and sub-millimeter wavelength ranges. The light curve of the event is depicted here in both optical and ultraviolet wavelengths. The number of days since the initial detection is plotted along the x-axis, while the apparent magnitude is displayed along the y-axis. When it comes to astronomy, the magnitude of an object's brightness is proportional to how much smaller it is. After its detection, astronomers observed a red hue along with a dramatic ascent and decline for around 4 days. After that, there was a pause in the progress, and the color turned a deeper shade of blue. This is a photograph of the incident captured by the Hubble Space Telescope. AT2022 CMC was a very uncommon object, due to its exceptionally high luminosity over the whole electromagnetic spectrum, as well as its quick growth on a timescale of only a few days. Around 100 intense transients are found by astronomers every single night, but none of them have such exceptional qualities. In order to get the solution to their question, which was, what caused this bright flash of light, they looked at the light curve. In the study that they wrote, the team compared AT2022 CMC to 3 known transient classes that display fast optical variability and the existence of radio and X-ray equivalents. These transient classes include kilonovas, gamma-ray bursts, and luminous fast blue optical transients, or LFBOTs. Kilonovas are fleeting astronomical phenomena, that can arise from the merger of two neutron stars or from the merger of a neutron star and a black hole. These occurrences result in the production of a great deal of chemical elements that are heavier than iron. The first neutron-star merger was discovered in 2017, and the initial color and quick expansion of the light curves of the two events were similar to one another. Both occurrences occurred in the same region of the sky. However, there were two key distinctions between the two. To begin, given to the low ejecta masses that are anticipated for kilonovas, it is anticipated that the luminosity of kilonovas will be orders of magnitude lower than AT 2022 CMC. In addition, as the synthesized components are created, kilonova models progress from blue to red, whereas this transient progressed from red to blue. After then, astronomers made a parallel between this event and a typical example of a luminous fast blue optical transient, also known as an LFBOT. It is a poorly understood class that is probably connected to the collapse of a star that leads to the formation of a black hole. The X-ray and radio waves that were produced in response to the two occurrences were similar to one another. However, astronomers discovered two significant deviations from the norm. AT 2022 CMC had a much deeper red coloration than a regular LFBOT. In addition, an LFBOT that has a long-lasting blue component has not been found as of yet in any of the LFBOTs that have been discovered. These characteristics substantially worked against the likelihood of this happening. The final step for the astronomers was to draw parallels between this cosmic event and a conventional gamma-ray burst, abbreviated GRB. The afterglow of a gamma-ray burst can be identified by its extremely high intensity, distinctive red color, and quick decay. The sole distinction is that the radio and sub-millimeter emissions lasted for an extended period of time, but the X-ray emission changed over time. The signal strength remained 100 times greater than the afterglow of any gamma-ray burst that has been observed to this day. Based on these considerations, AT 2022 CMC cannot even be classified as a gamma-ray burst. Therefore, the only alternative that accounts for all of the traits that have been seen is a tidal disruption event that resulted in the formation of a relativistic jet. The unfortunate star was traveling on a path that was practically parabolic when it got too close to the supermassive black hole and was torn apart into a shower of gaseous debris. This is when the event began. Roughly half of the mass was retained close to the event horizon, which caused significant shock waves at the point where it crossed over into itself. A pair of relativistic jets were produced as a result of the rapid spin of the black hole, which caused the shocked gas to first circulate and subsequently form an accretion disk around the black hole. Do not forget to hit that subscribe button and turn on post notification for more interesting discoveries. The occurrence took place at a redshift of 1.19, which is equivalent to around 8 billion light-years distant. Because of this, the projected tidal disruption event known as AT 2022 CMC is the one that has been discovered to be the farthest distant to date. Because it is so brilliant, scientists have calculated that each year the black hole consumes the equivalent of approximately half the mass of the Sun. Because the event was created by the tidal disturbance of a star by the supermassive black hole at the center of the galaxy, its position should match with the nucleus of the galaxy if the James Webb Space Telescope is successful in finding the host galaxy. This cosmic event is compared by astronomers to a variety of other phenomena that have previously been observed, such as kilonovas, luminous fast blue optical transients, LFBOTs, and gamma-ray bursts, GRBs. They come to the conclusion that none of these potential theories can adequately account for the qualities that were noticed in the incident. Instead, a tidal disruption event, often known as a TDE, is the most likely explanation for how a relativistic jet was created. Because the event took place at a redshift of 1.19, it is the most distant jetted TDE that has been discovered so far. The fact that this event produced relativistic jets, that it was directed in our direction, and that it could be spotted at optical wavelengths within hours of its occurrence sets it apart from other similar occurrences. This discovery may lead to the birth of new avenues for the investigation and detection of extremely rare astronomical occurrences, as well as the black holes that cause them. Strange new discovery leaves scientists stunned. Click on the next video to find out more.